With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, the problem states that a uniform rod of mass m and length L hinged at the center is rotating in a horizontal plane with angular speed omega naught. Now two objects each of mass m are kept on the rod near the hinge on both the sides. Now they start sliding towards the ends. We have to find the omega of the rod finally. So let's understand the concept. So here we have a rod of mass m and length L, and there are two objects of mass small m at their center, and this whole system is rotating with the angular speed omega naught. So this is the initial situation, and in the final situation these masses, they are at the ends, they have slipped to the ends, and still the rod of mass m and length L is rotating about its center with some new angular speed omega. So all we have to find is the value of omega now, right? So as we can see, this is the final situation. As we can see, from initial to final situation, net external torque, taking these two masses and the rod as a system, so net external torque acting on the system is 0, right? So that's why angular momentum will be conserved. So let's talk about the initial angular momentum. So initially the angular momentum will be due to the rods plus the masses. So as we know, angular momentum is written as I into omega, right? So that would be I1 omega 1 is equals to I2 omega 2, correct? I1, so the total moment of inertia in the initial situation would be moment of inertia of the rod about its center, which is ml square by 12 plus moment of inertia of the two masses. So as the two masses are lying at the axis of rotation only, so that's why separation is 0, so their moment of inertia will become 0 into initial omega, which is omega naught, that would be equals to final moment of inertia. So a moment of inertia of the rod would be ml square by 12 only. Now the moment of inertia of one mass, as it is at a distance what, L by 2 from the center, so its moment of inertia will become md square, d value is L by 2, and same with the other mass as well, as it is also lying at a distance L by 2, so into 2 divided by omega, right? So now we can see this is written as, so L square will get cancelled out, so what will remain with m by 12 omega naught is equals to m by 12 omega plus this is 2m by 4, so that would be m by 2 into omega, right? So we have to write the value of omega, so let's multiply divided by 6, so that would become, and now we can cancel 12 as well, so this is written as m omega naught is equals to capital M plus 6m times of omega. So from here the value of omega will be m omega naught divided by capital M plus 6 into small m, right? So now we can choose accordingly, so which is there in the option B. Okay, I hope this helps you with the answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.